is a coefficient of this logarithm expression. So I'll say 2 times log 10 to
10
be
to be
10.
10.
And
And
if
if
you
you
remember
remember
the
the
logarithm
logarithm
law,
law,
when
when
you
you
have
have
something
something
like
like
log
log
a to be 10, when the number and the base they are the same, the value of that expression is 1. If you have log 10 to base 10, it is 1. You
you
have
have
log
log
1
1
to
to
base
base
1,
1, it
it
is
is 1.
1. You
You
have
have log
log
10
17
to
to
base
base
17.
17.
The value of this expression, if you evaluate it, is 1. So which means log 10 to base 10 is 1. So I have 2 times 1. This is equal to 2. So
The
the simplification,
simplification,
or if
or
I
if I
try to
try to
evaluate
evaluate
this
this
expression,
expression,
this
this
logarithm
logarithm
expression
expression
here,
here,
I
I
should
should
have
have
2.
2.
Log
Log
100
100
to
to
base
base
10
10 is
is 2.
2. All
All right,
right,
so
so I
I
hope
hope I'm
I'm
not
not
too
too
fast.
fast.
If
If
there
there
is
is
a
a
point
point
that you
that you
don't
don't
get,
get,
you
you
can
can
ask
ask
questions.
questions.
So
So
for the
for the
sake of
sake of
clarification,
clarification, I'm going to
re-explain
re-explain
this.
this.
That's
That's
the
the
log
log
100
100
to
to base
base
10.
10.
So
So
what
what
I
I
said
said
is,
is, when
when
you
you
have
have
this
this
log
log
100
100
to
to
base
base
10,
10,
the
the
first
first
thing
thing is,
I
I
want
want
to
to
represent
represent
this
this
number
number
here,
here,
my
my
value,
value,
as
as
an
an
index
index
of
of
my
my
base.
base.
So how
So
do
how
I
do I
do
do
that?
that?
I
I
said
said
10
10
times
times
10
10
is
is
equal
equal
to
to
100.
100.
So
So
which
which
means
means
100
100
is
is
the
the
same
same
as
as
10
10
raised
raised
to
to
the power
power
of
of
2.
2.
All
All
right.
right.
So
So
I
I
have
have
log
log
10
10
squared
square
to
to
base
base
10.
10.
So
So
now
now another thing is I want to take away this index or this power
from
from
here,
here.
the
The
value
value
I
I
have
have
here,
here,
I
I
want
want
to
to
take
take
it
it
away.
away.
So
So
from
from
logarithm,
logarithm,
when
when
you
you
have
have
something
something
like
like
this,
this,
you
you
bring
bring
it
it
to
to
the
the
front
front
of
of
the
the
logarithm
logarithm
expression.
expression.
This
This
is
is
the
the
logarithm
logarithm
expression. So
expression.
I'm
So I'm
bringing
bringing
these
these
two
two
to
to
the
the
front
front
of
of
the
the
logarithm
logarithm
expression.
expression. Now I have
Now I have
log 10
log
to
10
base
to
10.
base 10.
All
All
right,
right,
this
this
is
is
the
the
same
same
as
as
2
2 times
times
log
log
10
10
to
to
base
base
10.
10.
Now
Now
I
I
said
said
there
there
is
is
a
a
logarithm
logarithm law
law
or
or
a
a
logarithm
logarithm
rule
rule
that
that says
says
when
when
you
you
have
have
the
the
value
value
and
and
the
the
base,
base,
if
if
they
they
are
are
the
the
same,
same,
then
then
the
the
value
value of that expression is 1. And
and
I
I
said
said
if you
you
have
have log
17
17
to
to
base
base
17
17
is
is 1,
1,
log
log 1
1
to
to base
base
1
1 is
is 1,
1,
log 10 to
10 to
base
base
10 will also be 1. If you have log a to base a, the value will be 1. So here I have log 10 to base 10, and log 10 to base 10 is 1. So I have 2 times 1
1
is
is
2.
2. So
So
yeah,
yeah,
that's
that's
how
how
we
we have
have
2
2
here
here
as
as
the
the
value of this logarithm expression after simplifying. All right, so we move to the next question.
so
So
this
this
is
is 2
2
raised
raised
to the power of 3 times 2 raised to the power of 4. This is the addition rule or multiplication rule, addition rule
addition rule
in
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 indices.
indices.
So
So
when
when
you
you
have
have a
multiplication
multiplication
sign
sign
between
between
two
two
indices numbers, between numbers in indices form, you have a multiplication sign between them. What you do is, since the numbers are the same, write the numbers
numbers
out
out
and then
and
you
then you
sum
sum
of
of
their
their
index
index
or
or
you
you
sum
sum
of
of
their
their
power.
power.
That's
That's
3
3
plus
plus
4.
4. So
3 plus 4 is 7, so you have 2 raised to the power of 7. So this is how you go about questions like this. All right, so
the first
thinking
thing,
this
this
is
is
addition
addition
rule.
rule.
You
You
add
add
up
up
the
the
powers
powers.
or the index, and then you write out the number 2 raised to the power of 7. If you are going to simplify this, you can actually write out the value of 3 raised to the power of 7 in the question. If
If
not, you
not,
can
you can
just
just
leave
leave
your
your
answer
answer
as
as
2
2
raised
raised
to
to
the power
power
of
of
7.
7. All
All
right.
right, so
So so these are the questions from the last test, and these are the solutions. So when you see questions like this, I believe you guys should be able to address them. You should be able to get the solutions. All
all
right.
right, so we'll move on to past questions from different years. Okay, let me continue from there. So all of these are all basis or the foundation of indices, and this foundation are what we are going to build on
You
to
to
progress
progress
in
in
when
when
solving
solving when
real exam questions. So since we already have the foundation, and one thing about foundation is we make sure the foundation is strong enough so that we can actually build efficiently
efficiently
from
from
there.
there.
All
All
right,
right.
so
So I'm going to pick a logarithm question
Recording in progress.
All right, so we have this question from the past question. It says log 9x squared over
over
y
y
cubed
cube
to be
to be
7.
7.
We
We
have
have
to
to
evaluate
evaluate
this
this
value
value
in
in
terms
terms
of p and q. So the question says if log x to be 7 is equal to p and log y to be 7 is equal to q,
of
evaluate
evaluate
log
49x
49x
squared over
y
y
cubed
cube
to be
7
7
in
in
terms of
terms
p
of
and
p
q.
and q. So I'm going to explain what we mean by this question. So what I mean is we need to find the value of these where we only have p and q and maybe a
A
number
number
as
as
the
the
result.
result. So when we solve for this, we don't want to have x or y in the result.
So what we are simplifying, the value we should get should be in terms of p and q. That is, it should be in coefficients of p and q. So when
When
we
we
solve
solve our answer, we should be getting something like x. We should get something like 7pq or
19 pq, something like that, or 1 over 2 pq. So what we are, the value we should get should be in coefficients of p and q. That's what we are saying we should do in this question. So we already know log
x to be 7 is p and log y to be 7 is q. So what we are going to do is we are going to try and simplify this logarithm expression.
Okay, so I'm going to do that on this side of the board. So this is log 7. So the first thing is I'm going to divide this one after the other. So this is the same as log 49x squared to be 7 divided by log y cubed to be 7.
What did I do? I simply differentiated this value.
Here. All right, that was what I did. So I did divided by log y cubed to be 7. But now, you remember in indices, all right,
Or
indices,
there is something
we do when we say it's
we do
differential rule.
when we say
When you have
the differential rule.
it changes to addition. When you have division, it changes to subtraction. But now, logarithm is the inverse of indices. So now, in logarithm, when we have divide, it becomes minus. When we have divide,
it becomes minus.
When we have multiplication, it becomes plus. Now, you can see here that we have a division sign here. So this division sign here is not going to be written as division. It's going to be written as minus. So we are
trying to simplify this expression here. So we have log 49x squared to
minus log y cubed to be 7. So I can actually combine this together. If I want to do that, I'm going to change this
subtraction sign to division, and I'm going to have this. I'm going to write log 7, right? And I'm going to
have 49x squared divided by this. So I can actually solve for this first. How do I do that? So in this part of my question, I know that log
y to be 7 is equal to q. So here, you remember when we were solving
in one of those questions, as I said, when you have a power, you can actually bring it to the front of the logarithmic expression to be a coefficient. So this is going to become 3 log y
to be 7.
Remember,
log y to be 7 is what? Q.
So I can substitute q for log y to be 7, all right? So this will become 3 times q. Instead of log y to be 7, I have 3 times q. So this will be 3q.
I have solved for log y cube to be 7.
So now I'm moving over to this side. If you look properly, you will see that there is a multiplication sign. I can rewrite this as log 7 49 times x squared.
All right. Now remember what I said.
Remember what I said about addition and multiplication, division, and subtraction in logarithms. Now, because I have a multiplication sign here, I will
simplify this, right? And it will become addition. So this becomes log
49 base 7 plus log x squared base 7. All right.
So I have this. So now I'm going to continue from here. I'll say log
49 to be 7 plus. Now I want to solve for log x squared base 7. Don't forget we have that the value of log x to base 7 is p.
So
just
just
like I
like I
did
did
here,
it,
I
I
brought
brought
the
the
power
power
to
to
become
become
a
a
coefficient
coefficient
of
of
the
the
logarithm
logarithm
expression.
expression. I'm going to do the same thing here.
I'll have 2 log x to base 7. All right. So log x to base 7 is p. So this will become 2 times p, which should be 2p.
So I have this.
So
So now
now
I've solved for the value of log
x squared to base 7 to become 2p. And I've solved for the value of log y cubed to base 7 to be 3 cubed. So I have this. Now, what is left for me to
to
solve
solve
now?
is
Log
log
49
49
to
to
base
base
7.
7.
So
So
I'm
I'm
going
going
to
to
continue
continue from down here.
log 49 to base 7. So what the next thing I'm going to do is I'm going to rewrite this 49 as a power of 7, or I'm going to
To
express
express
it
it
in
in
powers
powers
of
of
7.
7.
So
So
this
this
will
will
become
become
49
49
is
is
equal
equal
to
to
7
7
squared,
square,
right?
right?
So
So
I
I'll
have
have
log 7 squared to be 7. And this will become 2 log 7 to be 7. Remember when I said when you have the
value and the base are the same, then that logarithm
evaluates
evaluates
to
to
1.
1.
So
So
this
this
will
will
become
become
2 times 1, which is 2. So I have my log 49 to be 7 as 2. So if I'm going to add everything up together, I'm going to have 2 plus 2p
p
minus
minus
3q.
3q.
So
So
here,
here,
this
this is the
the solution, or this is the evaluation of this logarithm expression here in terms of p and. So as you can see, like I said, we only have p and
and
q
q
as
as
variables
variables in our
result.
result.
We
We
don't
don't
have
have
x
x
or
or
y
y.
because we are asked to express the answer in terms of p and q. So you can see here we have coefficient of p and we have coefficient of q. So the
So the
answer is
answer is
only
only
expressed in
expressed in
terms
terms
of
of
p
p
and
and
q.
q.
So let me
So
go
let me
over
go
it
over it
once
once
again.
again.
So the
So the
first
first
thing is when you have the question, we're given this in the question log x to be 7 is p and log y to be 7 is q. So what
so
I
what I
did
did
was
was
I
I
simply
simply
came
I
over
came
here
over here
to
to
simplify
simplify
the
the
logarithm expression. Division becomes subtraction, addition becomes multiplication becomes addition. So from there, I simplified
one
one
after
after the
the
other.
other.
I
I
simplified
simplified
individually.
individually.
Log
Log
y
y
cubed
cube
to
to
be
be
7
7
was
was
simplified
simplified
using this process to get 3q. And I did the same thing with log x squared to be 7. I simplified it to get 2p. And
and
then
then
the
the
same
same
process
process
for
for
log
log
49
49
to
to
be
be
7
7
to
to
get
get
2.
2.
And
And that
that's
was
how
how
I
I
had
had
2
2 plus
plus 2p minus 3q as my answer in terms of p and q. So if you have questions, you can ask them before I move to the next before
before
I
I
move
move
to
to
the
the
next
next
example
example
here.
here.
So
So
all
all
of
of
this
this
is
is we
we're
are
just
just
building
building
on
on
the
the foundation.
foundation of indices and logarithms that we've treated in the last classes. So you have the foundation, and with the foundation you can
And
just
just build on it. So all of these questions
are just they just need you to simplify, bring them back to the basis of logarithms and indices, their basic rules, and then you can actually solve
solve
for
for
them.
them.
So
So
you
you
simplify
simplify
first,
first,
you
you
use
use
your
your
rules,
rules,
and
and
you
you
get
get
your
your answer.
answers. So if you have questions, you can ask. Something is unclear, we'll move to the next question.
All
Right.
right. Next question says, this marker is running out of ink. All right. So I have log
So
So
I
I
have
have
something
something
like
like
this.
this.
So
So
here
here
I
I
have
have log x to base 5. So here is another aspect of logarithms. And here I have log 5 to base x. So there is a logarithm rule that says when you have log a to base n, it is the same as 1 over log n to base a. So I have log a to base n. This is the same as log n to base a. What did I do? I'm simply inverting the value of log a while switching the bases. I have this as my value. Here it becomes the base. N is my base. Here it becomes the value. So this is the same as this. Log 7 to base 5 is the same as 1 over log 5 to base 7. This is what we call inversing of logarithm expression. All right, so since we know this, we can actually inverse this particular logarithm expression here. So how are we going to do that? So what I would like to do is I would want to invert the value of my logarithm here to become log x.
All right.
All right, so I can also invert this to become log 5.
All right, so this will become log.
All right, so this will become log.
Okay, since I want to invert this,
since I want to invert this, I'll have 1 over
log
5 to base x,
right?
Plus
is equal to 3.
Is equal to 3.
So here
I have 1 over log 5 to base x plus 2 log 5 to base x. Now you can see I have log x to base 5 here, and I have log 5 to base x here, and I have log 5 to base x. So let's say log 5 to base x is equal to p. Right? I want to make this as a variable. I want to make this log 5 to base x as a variable. When I solve for the value of this variable, then I can use the variable to get the value of my x. Are you with me? So I'm going to replace anywhere I have log 5 to base x, I'm going to replace it with p. So I'll say you can use any variable. You can use d, you can use a, you can use y, as far as the variable does not conflict with the one in the question. So I'm saying 1 over p, because I have log 5 to base x, plus 2p is equal to 3. All right. So from here, I'm going to try and solve for p. I can use, because this is the same as 2p over 1, right? I can use LCM to find the value. I have here p. P in p is 1. 1 times 1, 1 plus 2p square. P times 2p is 2p square. So this is equal to 3. Here I can cross multiply, and I'll have 1 plus 2p square is equal to 3p. How did I do that? I cross multiply. I multiplied the whole of this by 1, which is still this, and I multiplied this by p. So cross multiplying equals 3p. So now here we are led to a quadratic equation. So this will become 2p square plus 1. I'm bringing this 3p over to this side. So this will become minus 3p equals 0. So I can rearrange this in the proper format of writing quadratic. So I have 2p square minus 3p plus 1 is equal to 0.
Let me go over it again.
I said the first part here is I want these two logarithm expression to look similar. All right. And a way to do that is to invert one of them. I can either invert this or I invert this. So in my case, I chose to invert this. So inverting this means 1 over the value is going to become the base, and then the base is going to become the value. So that's why I have log x to base 5. So after doing that, I took this expression, this logarithm expression, to become p. And then anyway I have this logarithm expression, all right, I'm replacing it with p. So yeah, I have 1 over p plus 2 times this logarithm expression, p. Then I used LCM, and I arrived at this quadratic equation. So yeah, I have to solve quadratic. I have to solve this quadratic equation, which we'll treat in the coming classes. But for now, let's just know that we are to find a product such that when we multiply it, we are going to have 2p square. And when we add it, we are going to have minus 3p. So that product is, we are simply looking for the factor of 2p square such that when we add them, we're going to get minus 3p. And a very good factor I have found is minus 2p and minus p.
If I multiply this,
If I multiply these two together, I'm going to
squared.
get 2p squared.
If I add them
If
together,
I add them together, I'm going to get minus 3p.
So what I'm going to do
So what I'm going to do is I'm going to take these two factors and substitute it with this minus 3p I have here. So I have 2p squared minus 2p minus p plus 1. So here I'm going to collect like terms. 2p squared minus 2p minus p minus 1. Why did this change sign? Because we have a subtraction sign here. So when we have a subtraction sign here, the next sign coming in the bracket is going to change. If we have plus, it's going to change to minus. If you have minus, it's going to change to plus. Why? Because subtraction is an inverting sign. When subtraction multiplies another sign, it is going to change the sign. Minus times plus, minus. Minus times minus, minus. So a negative sign is an inverting sign. So that's why I'm going to change this to negative. So here I can pick the common factors in the bracket. So this is 2p. 2p is common in this bracket. So I have p minus 1 because 2p in 2p squared is p. 2p in 2p is 1. So I have minus. What is common here? In this bracket, what is common is 1. So 1 open bracket, p minus 1. So I'm going to pick these two. Remember, this what is in these two brackets must be the same. So I can pick one of them, p minus 1, and I have this 2p minus 1. Don't forget, I have equal to 0, equal to 0, equal to 0. So here, this is the same as p minus 1 equal to 0, or 2p minus 1 is equal to 0. So this becomes p is equal to 1, or 2p is equal to 1. So I have p is equal to 1 over 2, or p is equal to 1. Now I have gotten the value of my p. But that is not what I was asking the question. The question asks me to find the value of x. Now, how do I find the value of x? Don't forget, I have this expression here. All right, this expression says log 5 to base x is equal to p. Log 5 to base x is equal to p. So I'm going to continue my workings here. It says log 5 to base x is equal to p. Let me use the first value of my p, which is 1. So I'll say log 5 to base x is equal to 1. So I can use, remember the conversion from indices to logarithms. I hope you guys wrote that down. Converting from indices, all right, to logarithms. So yeah, this will become x raised to the power of 1 is equal to 5.
So x raised to the power of 1 is the same as x. So x is equal to 1. X is equal to 5. So that's the first value of my x.
Now for the other value of p, where I have p is equal to 1 over 2, I can also replace this p with 1 over 2 and say log 5 is x is equal to 1 over 2. So this is the same as x raised to the power of half is equal to 5. So what I will do here is I'm going to multiply both powers by 2. I'm going to multiply both powers by 2 to get rid of this fraction, or to get rid of this 1 over 2. So I'm going to say this is the same as 5 raised to the power of 1, I multiply by 2, and this I multiply by 2. This is going to cancel out this, and I'm left with x raised to the power of 1 is equal to 5. 1 times 2 is 2. So x is equal to 5 squared. And if you simplify this, x is equal to 25. So I have the value of my x as 25, or x is equal to 5. So when I solve for this expression here, log x to base 5 plus 2 log 5 to base x equals 3, I have my answer as x equals 5 or x equals to 25. Those are the values of my x. So if you have a question, you can unmute yourself and ask. If you have something you are unclear with, you can unmute yourself and ask. All right. If you have questions, you can unmute yourself and ask them. Before we move on, we'll take one more example before the end of the class. We'll take one more working example before we move to the end of the class. So if you have a question, you can ask them now. All right, so in absence of no questions, we'll take the last example and we'll call it a day. So I'm going to pick an indices question this time from the past in index
the one I have here. So I have 7x squared minus 4 is equal to, instead of 1, I'm writing 7 raised to power of 0. Now, because the values are the same, I can also I can equate the indexes. So here I can say 4.
All right, so since I have x
All
squared
right.
minus 4 is equal to 0, I can collect like terms and say x squared is equal to 4. What did I do? I brought this 4 to the right hand side, and because I'm switching sides, the sign is going to change. So from negative sign to a positive sign. So here I can say x is equal to plus or minus square root of 4. Why do I have this plus or minus sign? So when we are dealing with a root that is a positive number, like that's an even number, we are going to have this plus or minus sign, because anytime we are multiplying that root by a positive number, whether it is positive or negative, it will give the same. What do I mean? Minus 2 times minus 2 is going to give me 4. Plus 2 times plus 2 is still going to give me 4. That's why we have plus or minus. So it only works for even roots. So if this were to be 3, we won't have this plus or minus sign, because minus 2 times minus 2 times minus 2 is going to give minus 8. But 2 times 2 times 2 is going to give you 8, which is different. So this only works for even roots. Even roots like 2, 4, 8, 6, 10, 12,
10, 12, 16, 18, 32, thereabouts. Here I have plus or minus 4. So here is x is equal to square root of 4 plus square root of 4, or x is equal to
square root of 4.
minus
So square root of 4 is
4
2.
is 2.
So
So
x
x
is equal to plus 2, or x is equal to minus 2. So I have the values of my x here as plus 2 or minus 2 for this logarithm expression. If you have questions, you still have time. We have like 3 minutes more to ask your questions. We address them and then we call it a class. So I expect you all to practice your past questions as you're studying. You grab your past questions, you practice your math questions, and not only mathematics, you have general paper, English, for those that are doing science subjects, government, physics, chemistry. You just keep practicing, because that is what brings success. So you keep practicing, because at the end of the day, all of these questions are repeated questions. All of these topics we've been treating, they are what we see in past questions. So if you can solve something like this, it means when you meet a similar question in the exam, or you can also go ahead and smash it. Do you get it? So that's how it works. So if you have any questions, a part where it was unclear to you in the explanation, you can ask, or you have a question that you want to ask, you can bring it up right now. So I expect everybody to have questions, because if you actually practice, you might stumble on something that you don't understand. So you can actually bring them during the class. For like the last minute of the class, we can actually go through them together. You're helping yourself and you're helping others in the class. All right, so I'll take the silence as no question, and we'll call it today. So I'll see you guys in the next class. Enjoy the rest of your day. Yeah, and keep solving, keep working, keep calculating, keep smashing it. I'll see you guys. Have a nice day.